Welcome back. Here is a good problem based on the friction and a variable force. See here, a block of mass 4 kg is placed on rough horizontal surface of coefficient of friction 1 by 4. By the application of force, the problem is find after what time the body starts, what is the maximum velocity, and after what time body will come to rest. These are 3 questions. After what time body motion will starts, maximum velocity, and after what time the body will come to rest. See here, when coefficient of friction is given, then the limiting friction or maximum friction opposed by the applied force is 10 Newton. After 10 Newton, the body is ready to move. Suppose see, by giving the force against time graph, the applied force will become 10 Newton after a time of this slope is a constant. So here 10 Newton takes place after 2 seconds. So here the body will start motion after 2 seconds only. Here motion starts. Suppose if you draw a net force against time graph, the force will be 0. That force at a time of up to time of 2 seconds, and after 2 the net force will be changes here 20, but opposing force is 10, so net force is equal to 10 up to 10, and the value will be changes up to this 6. Here will becomes 0 net force. After that one, here 6 to 8, the force will be decreases, effective force will be changes by the friction is also increases from 0 to -10, means oppose the motion. And when the force is 0, external force, then body moves with only opposing force of friction only. So it is the net force against time graph. Now in this case, see, impulse is given by change in momentum. Area under FT graph gives change in momentum. Then in this case, net force for this triangle, half base is 6 minus 2 4, and height is 10 Newton, is equal to m times of m into v minus u. Start from rest. So from this equation, v is equal to 5 meter per second. If applied force is greater than limiting friction, body starts motion at the time of only 2 seconds. Okay. Now, in this case, if you take the graph, the area under impulse, force under time graph is gives impulse. Here for this time 6 to 8 seconds, after 6 seconds, 6 to this 8 second, what is going on? At the time of 6 seconds, the velocity becomes 5, and impulse is half base into height. Here base is 2, height is -10, and this is final velocity minus initial velocity. For this situation, initial velocity 5, final velocity is 2.5. Remember, at the time of 8 seconds, the velocity reduces from 5 meter per second to 2.5 meter per second. And after this one, external force is 0, only friction is there. Due to that one, body will be stopped after an additional time of 1 more second. Then by using this equation, v is equal to u plus at. For this last situation, after 8 seconds, final velocity is 0, and at the time of 8 seconds, the velocity is 2.5. Acceleration is frictional force by mass, that is 10 by 4 into t. So after 1 more second of 8 seconds, after 8 seconds, the body will be come to stop, rest. The total time is here 8 plus 1 more second is after 9 seconds of the force applied, the body will be come to rest. Thank you.